Good evening, students. We will discuss about maxima and minima for two variable functions. We already discussed the maxima and minima for single variable functions. So, same way we can proceed like the same one variable function. We have to apply the same principle which is the find out the maxima minima of two variable function. Two variable means multivariable functions. That means maxima and minima for two variable functions. For two variable functions, maxima and minima for two variable functions. More than one variable means it is several variable or multivariable functions. Okay, let us consider a function z which is a function of x and y. So we consider z is a function of f of x and y. So how to calculate the maxima and minima for this function? So there are four steps we have to we will proceed in four steps to find out the maxima and minima of the function. Step 1. What we consider, now we have to, this is my function which is a function of x and y. So first is we have to find out the partial derivative of z. Partial derivative of z with respect to x, and also first order partial derivative. It is also partial derivative of z is on first order, and the first order partial derivative of z with respect to y. Okay, first order partial derivative of z with respect to x and first order partial derivative of z with respect to y. Then what we find out? Now find out, that means if we shortcut way, if we find out dou z by dou x, you have to find out, and dou z by dou y. You have to find out the z of function of f of xy. First we find out dou z by dou x, then dou z by dou y in the first step. Second step, we equate the two derivatives to 0. That means we have to take dou z by dou x is equal to 0 and dou z by dou y is equal to 0. Okay, we have to equate them to 0, just like the maxima minima of one variable. It is multivariable. Dou z by dou x equal to 0, dou z by dou y we will equate to 0. So we have to find out. Then when we equate to 0, we have to find out what is the value of x and y. Let x value is a and y value is b. Then a b is the value, is called the critical point, is called critical, is called the critical point of surface z is a function of xy. We have to find out this is the critical point of the surface. On the surface, suppose this is my pen paper. Wherever we get AB, suppose here we get AB, this is the critical point of the surface. Okay, then step 3. In this step 3, what we have to find out? find out the value of, we have to find out the value of R, S and T. We have to find out the value of these three factors. One is R, which is equal to dou rho square Z by dou S rho square. We have to find out T, which is equal to dou rho square Z by dou Y square. We have to find out S, dou rho square Z by dou X dou Y. We have to find out these three value of R, T and S. Then step 4, which is the condition, just like the first variable. If RT minus S rho square is greater than 0 and R value greater than 0, then the point AB, the point AB is called the minima. And the value, when we put this value in this function, then we get the minimum value by putting this value in f of xy, we get minimum value. Oh, massa right. Mari to devi na tote. Right. Second, first point. Second point, if RT minus S rho square is greater than 0, RT minus S square greater than 0 and R is less than 0, then the point AB is called maxima. Then the point AB is called maxima, and FAB, and if we put this value AB in XY, that means f of AB is maximum value. In place of x I write A, in place of B I write B. Whatever the value AB is, we get the maximum value. Third condition is, if RT minus S rho square is less than 0, then the point A, it is greater than but less than. If it is less than 0, then the point AB, then the point AB is neither maxima, nor minima. At point AB, we call neither maxima nor minima. If there is no R value, it is greater than 0, but R is greater than 0, we call minima. It is greater than 0, but R is less than 0, we call maxima. If it is less than 0, then the point AB neither maxima nor minima. In that case is equal to 0. If RT minus S rho square is equal to 0, then further investigation will be carried out. That means we have to take third derivative, fourth derivative, such type. Third derivative and fourth derivative, such type. It is easy for you. If I take one example, suppose we take one example, x cube plus y cube minus 3xy. This is equal to z, which is a function of xy. We have to discuss the maxima and minima. Maxima or minima. That means this equation is maxima and minima we have to find out. Maxima and minima. Okay. Then my first condition is that what? Now we have to find out dou z by dou x and dou z by dou y. These two things we have to find out. So we have to take dou z, this is z, dou z by dou x is equal to dou by dou x s cube plus y cube minus 3xy, which is equal to dou by dou x s cube plus dou by dou x y cube minus dou by dou x 3xy. Dou z by dou x hele 3x square. It is value 0, x is variable, but it is y is another variable. If we vary with x, it will be remain constant. So any derivative of constant is equal to 0 minus here x, so y is constant, 3 constant, y constant. We take outside 3y, derivative of x is 1. So this value will come as 3s square minus 3y. This is called dou z by dou x. Similarly, we have to find out dou z by dou y. Dou z by dou y, which is equal to dou by dou y of s cube plus y cube minus 3xy. Which is equal to dou by dou y s cube plus dou by dou y cube minus dou by dou y 3xy. Okay, here it will come 0 because x is variable. X is here considered as constant because we have to vary y. Dou y vary with y, small variable with y, but x is here, so x will remain as constant. Derivative of here is means 0. Here derivative is y, so 3y square. It will come 0, it will come 3y square. So it will come 0 plus 3y square. Next is derivative of minus 3xy. 3x will remain constant, come outside. Derivative of y is 1. That means 3y minus 3x, which is equal to 3y square minus 3x. Second step is we make dou z by dou x to 0 and dou z by dou y to 0 to find out x and y. Find out x and y. Okay. This is the second step condition for second step condition. Here is second step condition. dou z by dou x we equate to 0, dou z by dou y we equate to 0, and find out the value of x and y. Then that means dou z by dou x is equal to 0. That means 3x square minus 3y. 3x square minus 3y is equal to 0. Equal to 0. That means 3x square is equal to 3y. When come to this side, 3 will cancel. We get x square is equal to y. Okay, if we put here also, we get same equation. So what we do? We put this y value here. Y is equal to x square. So in this place we have to put here. Okay, putting the value of y in 3x square minus 3x, which is equal to dou z by dou y. Put karba. So what we do? Now 3 in place of y we put x square. That means y square means x square rho square minus 3x, which is equal to 3x to the power 4 minus 3x. We have to equate it to 0. So what we do? Now take 3 common. 3 common matlab x square minus x is equal to 0. Take this 0 by 3. 0. X to the power 4 minus x is equal to 0. Take x common. X cube minus 1 is equal to 0. Here two conditions arises. Either x is equal to 0. If we put x is equal to 0, entire thing will be 0, or x cube minus 1 is equal to 0. These two conditions arises. Either x is equal to 0 or x cube minus 1 is equal to 0. But x cannot be equal to 0. And if x is equal to 0, then this function will not exist. But x has some value. It is not equal to 0. That means x cube minus 1 is equal to 0. So x cube is equal to 1. 1 the q I can write. Same value we will get. So x is equal to 1. I get x is equal to 1. Put this x value either here or dou z by dou x. Here. Wherever I put this x value here. 3y square minus 3x is equal to 0. Put x value here 1. Hele 3y square minus 3 into 1 is equal to 0. So 3y square is equal to 3. Take outside, cancel. So y square is equal to 1. That means 1 square. That means 1 square. So y is equal to 1. So x is equal to 1, y is equal to 1. We solve it. So my critical point is 1, 1. This is called critical point. This is called critical point. So we have to find out. Next step is R, S, out T. We have to find out these three values. R is equal to dou square z by dou x square. So R is equal to तामने dou by dou x dou z by dou x. So dou by dou x dou z by dou x is equal to 3x square minus 3y. 3 x square minus 3y. Again we have to find out derivative dou by dou x 3x square minus dou by dou x 3y. So which is equal to, this is in 6x. This will be 3 constant, y also constant. So this is equal to 0. Okay, so that means r is equal to 6x. We get this r is equal to 6x. Similarly, we have to find out t. This is the value we get r. Then again we have to find out t. T is equal to dou rho square z by dou y square. That means dou by dou y, dou z by dou y, dou by dou y, dou z kainore eti 3y square minus 3x. That means dou by dou y 3y square minus dou by dou y 3x, which is equal to 6y. This is constant 0. That means your t value is 6y. Okay, t value. Then we have to find out s. Dou rho square z by dou x by dou y, but dou y dou x that ma karba karibo. That means we have to take dou by dou x, dou z by dou y. So dou by dou x, dou z eta y, dou z by dou y 3y square minus 3x, which is equal to dou by dou x into 3y square minus dou by dou x 3x. This is constant, is variable. A variable is constant 0. 0 minus 3 constant dou x by dou x equal to 3 becomes minus 3. Each your s value. So your s value is minus 3. Then what is the value of RST? Now R value in 1 1 critical point, x jagare I put 1, so 6. So t value in 1 1 critical point, we put y jagare 1 6. So here s value we get minus 3. Okay, this is the value 6 6 minus 3. Then what is the condition? You see, r value, my condition is that if rt minus s square greater than 0, r value less than 0. Here you see, what is the r value? R value is 6. That means greater than 0. This one, r value greater than 0. Means r value 6, so greater than 0. That means the point is called minima. That means 1 1 is called minima. Here we get what? Now r value greater than 0, because r is equal to 6 we get. Then next is whether we see that rt minus s square. Rt minus s square, what is the value? R is 6, t also 6 minus s square. S is minus 3 the square is equal to 36 minus 9 becomes 27. 27. That means rt minus s square greater than 0, 27, and also r is या ता रक्त जाई पिउनु मो पाखु कहीं आसु पिउछु रक्त गुड़ाकरे केते कष्ट रक्त बनाउछि ये रक्त पिउछि मस्ताते पड़ना लगे ना होगा गोटे मिनिट मारिदेवी how condition is that this one 27 RT minus greater than 0 and also R value greater than 0. When these two value are greater than 0 matlab RT minus greater than 0 R value greater than 0 then the point AB here 1 1 is called minima. Then find putting the value of fxy we get minimum value. That means 1 1 is called minima. So the critical point 1 1 is called minima, and the minimum value and minimum value केनता आसबा ना z is equal to f of xy value कौन थिला sq plus थिला रे sq plus yq minus 3xy sq plus yq minus 3xy. Now put 1 1. This is minimum value 1 ro q plus 1 ro q minus 3 1 y 1. 1 q hela 1 plus 1 minus 3. It will become minus 2. 1 plus 1 2. 2 minus 3 is equal to minus 1. This is called the minimum value. Point is called minima, and this 1 1 is called minima point, and this is called minimum value. In this way you can find out maxima and minima. Now it is over. Okay, next class we will study about the operator, quantum mechanical operators, unit 2. Okay, I will end here. मशा तो मत खाई दो।